The construction of Burj Khalifa was underway. The structure was somehow erected, and it was time to install the window panels. The engineers assumed it wouldn't be rocket science, so they didn't pay much attention to it. But then, something unexpected happened. Dubai's scorching heat, combined with the height of the world's tallest building, caused a major problem. Once the window panels were installed, the internal temperature during the day shot up to 100 degrees Celsius, 212 degrees Fahrenheit. At such high temperatures, entering the building became impossible. This became the biggest challenge faced during the construction of Burj Khalifa, and put the entire team in a difficult situation. Due to this, all interior design work had to be halted. Construction was on pause for 18 months, until a solution emerged that reignited the hopes of the struggling engineers and management. Welcome to Real Scope, another episode. The Burj Khalifa in Dubai is the tallest building in the world. At a height of 2,716 feet, this skyscraper pierces through the clouds. The total cost of construction reached $1.5 billion, but it wasn't just about the money. This structure is considered an engineering marvel in the history of modern architecture. How engineers, architects, and workers completed this masterpiece despite countless challenges, and how they solved those problems, is what we'll explore in today's video. Challenge number 1. Finishing on time. The engineers were given only 6 years to complete the construction. Out of those, 3 years were required just for designing. If they had spent 3 years only on design, they couldn't have finished construction in the remaining time. So they decided to begin construction without a finalized design. Thus, excavation work started in February 2004, while design continued alongside. Challenge number 2. Weak foundation. Usually tall buildings are built on solid rocks, but the site selected for Burj Khalifa had sandy or fragile stones. The question arose, can the world's tallest building be built on such a weak foundation? The answer lay in friction, a basic scientific principle. Burj Khalifa's foundation was made up of 192 solid steel piles, each driven 50 meters deep. The total building weight was equally distributed across these piles. Challenge number 3. Designing the structure. Emaar, the construction company, contacted a top-tier architecture firm in Chicago. Though the firm had previously designed several skyscrapers, designing the tallest building in the world was a whole new challenge. They needed to create a structure that could withstand the weight of millions of tons of concrete and steel, allow natural light to reach every floor, rise to 160 floors. After countless sleepless nights, they introduced a revolutionary new design, the buttress structure, used for the first time ever in the Burj Khalifa. Challenge number 4. Concrete drying too quickly. As the building grew taller, engineers faced a new issue. The concrete mixture dried up before reaching the upper floors. The only solution was a concrete suction system. Large pipes were installed from the bottom to the top, allowing the fresh concrete to be pumped upwards. This wasn't ordinary concrete. The total weight of concrete used in the Burj Khalifa was equivalent to 100,000 elephants. To pump this amount, 3 of the world's most powerful concrete pumps were imported to do the job. Challenge number 5. Lifting materials beyond 120 floors. After 3 years, 140 floors were constructed, breaking world records. But the cranes available could only reach up to 120 floors. Not only that, but the crane operators refused to work at even greater heights. So, engineers hired new crane operators from across the globe. Despite their different languages, they had one thing in common: no fear of heights. These operators worked 12-hour shifts at a height of 700 meters, and it was said that some even slept inside the crane cabins. Challenge number 6. The glass panel crisis. With only 2 years left until launch, the structure was completed. But 24,000 glass panels still needed to be installed. Due to Dubai's extreme heat and the building's height, installing the panels caused the internal temperature to rise to 100 degrees Celsius, 212 degrees Fahrenheit, requiring 10 times more energy for cooling. For 18 months, the team searched for a solution. Finally, renowned engineer John Zarafa came forward. He had developed a special type of glass that could reflect UV rays from the sun. Each of these custom glass panels cost $2,000, and they needed 24,000 of them. totaling $48 million. A dedicated factory was built to produce these aluminum glass panels, and within 4 months, they were manufactured and installed. Challenge number 7. Installing the top spire. As the building neared launch, one final component remained: a 136-meter-long solid steel spire, weighing 3.5 tons. No crane on Earth could lift it to the top. So, engineers decided to construct it inside the building itself. It was carried to the top in small pieces, then reassembled at the summit of the Burj Khalifa. Challenge number 8. Final polishing. Although construction was complete, the building was covered in years of dust and construction debris. Now it had to be cleaned and polished from the outside. There was only one solution: suspend workers with ropes to clean the 24,000 glass panels manually. Even today, Burj Khalifa's windows are cleaned this way. We hope you enjoyed this incredible episode from Real Scope. Thank you so much for your kind comments and support. See you in the next amazing video.